Hello and welcome to this first video in a short series about metals. And we're going to start by looking at the properties of metals. So first of all, we've got to understand what the word properties means. A property is anything that is true about a substance. Maybe its colour. Other things, does it conduct electricity? If it conducts electricity, that's a property of that substance. Melting point is a property of a substance. If I say, for example, that water boils at 100 degrees Celsius, that's true about water and is therefore a property. What happens if you hit a substance? Some substances will shatter. That's a property of a substance. Some will bend. Again, that's a property of the substance. And how dense is the substance? How heavy is each cubic centimetre? These are properties of substances. They're what make one substance, if you like, different from another. And the ways in which substances are different from each other. Okay, we're going to focus on one. We're going to look at electrical conductivity. We want to know whether or not a substance conducts electricity. In other words, will it let electricity flow through it? So first of all, we need to take a sample of a substance. Okay, we don't know what that substance is. It could be anything at the moment. Doing this with a gas would be kind of tricky, and probably with a liquid as well, but any substance in principle you can do this with. Okay, you want to find out if electricity will flow through that substance. That means you're going to have to make the electricity move, if possible. You need something that makes electricity move. That's a battery, or a cell, or a power pack. In this case, I've drawn a battery. You're also going to need some way of knowing if the electricity is indeed flowing. So you're going to need something like a bulb. And then you're going to connect those up like that. That's our testing equipment for conductivity. A battery and a bulb. Or anything that makes electricity move and anything that shows electricity is flowing. A meter would also work there. We're going to connect those now to our test substance like that. Now, if that test substance lets electricity flow, then that circuit will be complete. If it doesn't let electricity flow through it, then that circuit is not complete. So, if the bulb stays off, then electricity is not flowing through the substance because the circuit is not complete. And if electricity does not flow through a substance, then it is an insulator. On the other hand, if the light goes on, it's showing that electricity is flowing through the circuit, so the circuit must be complete, so that substance is letting electricity through and is a conductor. And without exception, all metals are electrical conductors. Some are better than others, but all of them are good at letting electricity through. So what are some other properties of metals? There's thermal conductivity. Do they let heat through? Generally speaking, all metals are good thermal conductors. That's why kettles that you put on stoves, pans that you put on stoves, they are made of metals because they conduct the heat through from the stove to the food or the water or whatever. There's malleability. Now you probably haven't heard of this one. This is to do with what happens if you hammer a substance, if you beat it. Okay? So, with a lot of substances, if you take something like salt or sugar or glass, if you hit them hard, like this, they tend to shatter. They tend to break. Most metals aren't like that. Most metals, if you do the same thing, instead of shattering, they spread out. They get thinner. They change shape. And that means we can shape metals. Malleability is a really useful property of metals because we can shape them by hitting them effectively. And that's how we shape things like swords, by beating the metal out flat and shaping them. Then there's ductility. Again, you probably haven't heard of this one. Let's take a piece of metal. Imagine grabbing the top of that and the bottom of that and pulling really hard. Instead of breaking, metals tend to get thinner and longer, and eventually they become wires. This is how you make wires. Good example, again, copper. Copper is a really good metal for making wires out of. It's highly ductile. Then there's density, how heavy the metal is. Now, if you're going to compare the heaviness of metals, you should use the same volume of each metal. So we usually choose 1 cubic centimetre. Density is the mass of 1 cubic centimetre of a substance. The denser a substance is, the heavier it is generally. So, if you take something like an aeroplane, you want to make an aeroplane out of metals with low density. You want your aeroplane to be as light as possible, so you choose metals with low density, and aluminium is a really good choice there. Melting point you should know about. It's the temperature at which a solid turns into a liquid. Boiling point you should know about. The temperature at which a liquid turns into a gas. And hardness is basically how easy a substance is to break. So, for example, an armoured car made out of tissue paper, not very useful. Armoured car made out of titanium steel, much, much harder. So, to sum up, we have been looking at physical properties. Now, these are physical properties. Later on, we'll look at what we call chemical properties. What reactions metals do. What happens when they react chemically with other substances. At the moment, we're just looking at physical properties. They include electrical conductivity. All metals are electrical conductors. All metals are good thermal conductors. Malleability and ductility, you should now know about. That's being able to shape a metal by hammering it and being able to make a metal into wires. Melting point and boiling point you should know about. That's the temperature, notice temperature at which things melt, and the temperature at which things boil. Density, the mass of each cubic centimetre of a substance. The denser an object is, the heavier it is. And finally, we're looking at hardness. How hard a substance is fairly straightforward. We've noted as well that the properties of metals tend to be linked to their uses. So we choose a metal with low density to make things that we want to be light. We choose a highly malleable metal if we want to be able to shape it easily. Okay, that's it for now. Thanks for watching, and I'll maybe see you next time. Bye now.